Okay, today is November 11, 2020. This is the meeting of the CSI Community Group. And the agenda today, we have a few items. Feel free to add to it as we go. First up, we have Jai Wei and the 128 byte length limitation for CSI. Jai Wei, you want to talk about this?
Yeah, sure. So basically, currently right now in the CSS spec, we have a size limits section which defines some general size limits for various kind of fields. So one field we have is string. So normally for string we have size limits which is 128 bytes. So this has been proved to be problematic for a lot of other files. For example, the node ID, and also there are some people complain that for some like Linux pass, 128 bytes is definitely not enough. So I just wanted to bring this up and to talk about it and say if folks have any idea how should we increase this, or like which lines should we increase this. So my proposal right now here is to change the ID to 256 length limits, and for all the file paths, I think 2000. I'm suggesting 2048 bytes.
So we've had the discussion about node IDs before, and we can reprise that discussion. What are you talking about with the file paths? Where do file paths show up in a?
Oh yeah. I mean, for file paths, it's basically just a target path here.
Oh, you're talking about like the
and
target paths and staging paths that get passed to the node.
Yeah,
Like,
and also volume paths. So I took a quick look at the CSS spec. I think there are three type of paths.
yeah,
There are like volume paths, target paths, staging target paths.
but those are under the control of the CO, and the CO can arrange
it's
can
controlled.
arrange for them to be less than 128 bytes fairly
It's controlled.
trivially. So like, what is the need to make them longer?
I mean, because there are people like creating issues and mention that when they try to have a longer target path, like it's giving out error or something.
Yeah, but I mean,
So
who is going to make the target path longer than 128 bytes? It would have to be the CO. Like, is this someone doing something weird with Kubernetes, or is it a different CO other than Kubernetes? Like, I'm just trying to understand what are people actually doing that's bumping into this limit?
I think for CSI node, for the node ID is Kubernetes, it's a CO, but for paths, actually, Salt, can you help to click on the node mount passes issue? Right after this one, this next one. Yep. And I think they mentioned this arrow comes from maybe like gRPC or some kind of protocol. But I guess the general idea is where the one to define the standard. So that's why they're trying to ask us to extend this.
About the mount paths, you can configure wirelib kubelet to be somewhere else. It can be pretty long path if you are crazy enough. But if you use wirelib kubelet, then you are safe and the path won't be longer than 128.
Yeah,
So for
Mhm.
target path or volume path in Kubernetes today, can you easily go over 128?
So it sounds like the person in this issue is complaining that the Kubernetes mount path already takes 90 bytes up to 128, and then they have a very long UID that causes spillover. So
But
this limit
who
was,
has the UID? The SP?
I
Or
think
the,
it's the volume ID, right? That's returned by
Well,
the SP during create volume.
and does that become part of
no,
the staging path or the volume path?
I think in the global path we use PV name, and in the pod local path we use UID of the pod and something else. I don't remember. Volume name?
It's not the volume ID.
We should never be using the volume ID, yeah, in a path. That would be weird. Because yeah, then all you need to do is return 128 byte volume ID and blow away all your path length limitations.
I have a bug in systemd that doesn't like the unit names greater than, I think, 512. So because each mount creates a systemd unit, at least if you're using systemd, so it creates problems. So arbitrary, like pretty large path names will create that much longer systemd unit name, and it's an issue. So this means that basically like 1024 or 2048 bytes for path is generally problematic. Jan, correct me if I'm wrong. And until like systemd also fixes it, or like we skip systemd.
I think both are equally probably. Yeah, systemd doesn't like a long path in mounts, and there is no workaround. Well, actually, nothing breaks, just systemd logs weird log messages. That's the only like bug. Everything else works, and you can mount and unmount the volumes as you want.
So what do you guys think? So do we want to at least extend it to like 256 bytes, or just leave the path as it is right now? I think we have a consensus on the node ID, right?
Wait, the node ID is complicated because it's checked in Kubernetes. You can't create the CSI node object with long IDs, node IDs. So that needs to be changed. It's not difficult, but you need a fixed Kubernetes version to use longer IDs.
Yeah, but I think in order to fix that, we need to change the spec first, right?
Yeah, sure.
So yeah, I'm just wanting to make sure that everybody agrees the node ID should change to something longer.
Well, so we've discussed this multiple times in the past, and we've always decided not to change it. So I think the question comes down to like, why is 128 bytes not enough, and why is 256 bytes going to be enough?
so on the node ID side, on GCP, what we've noticed is that, so what we do on GCP is for the node IDs, use a fully qualified path that includes the zone information as well as the node ID. And so if you have a very long zone name like Australia West, blah, or Australia something, something.
I think the longest one was North America Northeast 1A or something like that.
We are hitting that limit very quickly. And so at least for node ID, it is problematic.
But we think that a simple doubling is going to get us out of hot water.
That's a good question. So we want to increase it. What should that limit be for node ID? I think should partially be dictated by the limit that Kubernetes places on the name. These 128 character limits were kind of arbitrarily chosen and were always designed that if we had a problem with them, they could be loosened.
Yeah.
In this case, for node ID, we certainly have that problem. But the question, I guess, is what you're saying is what should the new limit be and what makes sense?
Yeah, I'm not opposed to increasing it, but like we wouldn't want to increase it by a little bit only to find out in a year that like it's still not big enough.
Right. So I think by convention, Kubernetes resource names can be up to 253 characters long, and this node ID surfaces itself in Kubernetes. So I think it would be good to just align it with that.
253 as opposed to 256.
Yes.
That's sort of a strangely chosen number.
It comes from DNS.
There you go.
Most of the object names are DNS subdomains or something.
So can we just point to an RFC and say this is why, and it's 253, and go bug the IETF if you don't like it?
I don't know. I don't really care what the limit is.
Yeah, I'm okay with 253.
Okay, so okay. So for all the other file passes in the Linux, like target pass, volume pass, we is the decision not to change it, or?
So I want to push back on why we wouldn't want to change it.
I think the main consideration is what Hamad brought up, is that system D can't handle paths longer than 512.
And that's fine. So, I mean, we can bump it to 512. We don't have to go higher than that. Can we do 512 safely?
Yeah, or at least we can at least double it to 256.
I guess the the caution might be that some SPs might be throwing errors if you pass in a path longer than 128 bytes. So even if we update the spec for backwards compatibility, we'd have to recommend that you try to keep it under 128 because older SPs will enforce the old limit. And then of course everyone can update their SPs and eventually
But I
support
guess
the new limit.
Oh, I see. Okay.
But the you know, if a CO starts sending longer paths, it might not work with an older SP.
That is possible. That would just be a very strange check for somebody to implement on the SP side.
Yes, I think I actually wrote the like the CSI sanity test to verify this because it was causing problems that the you know, lengths we were allowing longer lengths and that was causing a problem. So we're like, okay, we need to validate that the spec is being enforced. And so I think we actually added a test that says, you know, if you pass a path that's longer than 128 bytes, it's supposed to fail, which then encourages SPs to go add that check.
I see.
But like, I'm not really a fan of that kind of test in terms of like a conformance test, but there's a bunch of those kinds of tests in CSI Sanity that encourage you to be pedantic about your inputs, even if you don't really care. And it's sort of a bad pattern that I may have replicated.
Okay, so I think this will be a good learning lesson. Let's change it and see what happens. So in order to change it, we're going to need to update spec. We're going to need to update CSI Sanity. And then we'll need to update the COs, including Kubernetes.
The main thing is when we update the spec, I would just include a cautionary note that for backwards compatibility, 128 is safer, but we allow longer, up to 512. I mean, it's possible that there SP implementations that really can't handle ones longer than 128 bytes due to some architectural limitation inside the SP. It seems like that would be a really weird thing, but you never
So when
know.
we update the Kubernetes side, do we want to make this version dependent? If you are using CSI version 1.4 or above, you get the new limit. Otherwise, you get the old limit, or apply it everywhere.
It sounds like it's possible to accidentally violate the limit already. And so we can just keep that behavior and say, you know, try to keep it under 128, but we're not going to do any checks on the Kubernetes side.
Got it.
Does anyone remember if you're validating the node ID length in Kubernetes? We are using it in CSI node. Where else we are using it? In node object, I think we are using it also.
It is there as annotation and encoded in some crazy JSON. So I'm not sure what's the limit for annotations. It was 4 kilobytes.
Yeah, I think annotation size is pretty big. And in the CSI node object, I don't think we are validating actually. But
I
yeah.
saw it somewhere.
You mean for the node ID?
Yeah.
Yeah, it's validated in the API server.
Yeah, we do. CSI max length.
It's validated.
Okay.
If you have a node ID longer than 128, the CSI node creation will fail.
Just trying to find the max. Yeah, okay. $128. Yeah, all right.
Okay, so it sounds like conclusion is we'll update the paths from 128 to 512. We'll update node ID from 128 to 253. We'll include a note that 128 is the safer limit. And then update CSI Sanity to reflect the new limits, and then update the Kubernetes and CO side to reflect the new limits. Does that sound okay to everyone?
If we are using 512 as a limitation for system D, then we have to be mindful that system D escapes the path before it counts the limit. So it's actually, if it has slashes and backslashes and whatnot, then actually 512 will become more than 512. Like if we are using that as a guidance, system D as a guidance at all. But I just wanted to.
So whoever does the calculation on the Kubernetes side needs to basically look at the final character count. Or I guess system D does it internally, so we would have to, how would we handle that? Should we just make this lower to account for that potentially? I don't know if we can.
I think 256 should be easier to avoid that situation.
I am okay with 256. And in your PR, you can mention that why we're coming up with these limits. So when we inevitably revisit this.
Yep.
Okay, I'm going to put a quick comment in your pull request for Okay, any other comments on this issue? Any disagreement about the conclusions? Okay, let's move on to the next item from Jan, restoring and cloning volumes to a bigger size.
All right, so last time we sort of agreed that I should try, well, that it would be nice if we didn't need to change the implementation on the CO side, and we call create volume of 1 GB snapshot. If somebody calls create volume of 1 GB snapshot with 2 GB volume, then the snapshot should be restored to 2 GB, and if possible, the storage plugin should increase the size of the volume to 2 GB. So that means for block system based volumes, it should also resize the file system. So I tried that in AWS driver. It is possible. I have a link in the issue to the implementation. I just implemented X3 resize, not XFS, because it's kind of tricky to get the volume size from the file system point of view. You need to, it's different for each file system. But yes, it is possible for XFS, for X4. I didn't check any other file system. So if we really want it, if we really want to go this way, we can. It will be responsible of the storage plugin to see that it's restoring or cloning volume to a bigger size and do something about it on the next node stage or node publish.
I forget if we discussed last time, is there any downside to the CEO just calling node expand every time?
I remember reading the notes. Someone mentioned it's not efficient.
And like efficient how? I think efficient how? It might be actually like implementation wise. I know it's not. It's simpler to actually the CO calling node expand volume. That way the drivers don't have to all make the changes. But that does mean that like the wording should be maybe updated. So yeah, like we don't have to change like 100, like 10 or 20 drivers to all of them to handle the potential expansion.
What I noticed is that each driver, well, I checked GCE and Ceph and AWS, and each of them like copies Kubernetes code for the resize. It'd be nice if we had a library or something that we know it does the right thing and we could share.
Yeah, we have the shared mount library. We could put something next to that shared resize library.
Like a separate library. Like it is possible, definitely, but
or you can
the
even
administrative costs will be higher.
We could just like extend the mount library even potentially and add another function for resizing file systems.
Mm-hmm.
So coming back to this question of efficiency versus ease of use, what do people think?
I think efficiency does not matter too much here because, this operation is not a very frequent operation for the users. And from a developer perspective, it would be much easier for us to implement this if we do it from the sale side.
But wait, but don't you have to call it even if it's not resized, and that's why it's inefficient? I thought that the issue was it doesn't matter whether people are resizing their volumes or not. Like if you.
Yeah, I think the efficiency concern is exactly that on.
This would be literally every volume published, you'd have to call resize unless we have some state tracking on Kubernetes to know if it's needed or not.
But we do that, so we do have a state tracking actually. So
but for this specific situation, to know when a volume was, because the issue was like when you do create a larger volume from like a smaller snapshot, like the SP is going to tell you that it is the correct size, and so unless you know that it's not, you don't know how to, you don't know what state to track on the Kubernetes side to know that it still needs to be resized. So you could just always call resize to cover that case, but now you're in a super inefficient place. So the problem is like if we have state tracking on Kubernetes, how do we know to trigger when it's time to do that?
I guess why is calling resize every time inefficient?
Because I don't know, it's an extra RPC that you would call on every time a pod starts up for every volume, right?
But backing up, like if the snapshot is being restored to bigger size, then the PVC status is basically like a smaller size, request is bigger. So kubelet knows that, okay, this needs to be expanded. And
no, I think the problem is today it doesn't know that.
Yeah, the external provisioner has to be updated. Like that was the plan.
But how is it going to know? Like what's the signal it's going to get that says a resize is needed?
So the plan was like if we wanted to do this via CO was when the external provisioner like the restore happens, or whoever basically creates the PV sets the PV size to be the PV size to be what the user requested size, and the status of the PVC to be the snapshot size because that's what is available. And then the kubelet will know that, okay, PV is bigger, PVC state is smaller, so it needs to do node expand volume, and it will call that during the mount operation.
And if the SP had already done the resize out of band, then it's harmless.
Yeah, node expand supposed to be, it should be idempotent. Yeah, it should be harmless.
Okay, because that was where we got stuck during the last one of these meetings, was that we couldn't figure out a way to communicate from the SP back to the CO that you need to call the expand. And so it was going to be like either we always do it or we never do it. And you're saying now we have a third option, which is we're just going to go on the size information that Kubernetes has to decide whether to do it or not and ignore what the SP says.
Yeah, I think so. I think Jan Wei or someone was looking into making the changes to external provisioner, and it was possible, obviously. Like, yeah, it should be. It isn't very hard. Yeah.
So you're saying this third option is to use the size of the original PVC,
Or the size of the
the data
snapshot.
source?
Yeah, use the size of the data source.
What about the sources, another PVC? You check in the source of the, like the volume or the size of the PV or PVC? Which size are they supposed to be all the same, or they could be out of sync as well, right?
I mean, it's possible we could get the right value, but it seems like there's a lot of landmines here. I don't know. I'm confused because I thought that last week we had resolved this to say that this is the SP's problem to solve, and the SP needs to just do an inline resize at publish time if it needs it, and make it the SP's problem. So this.
I guess the main thing is that we are pretty sure we are going to have to change a lot of drivers to do this. And so I guess the thought is, as well, is there something that Kubernetes could do instead so that we don't have to change a ton of drivers?
Yeah, so sorry, I didn't attend last meeting, but from my understanding, I think what happened is when there is a request on the external provisioner side, the provisioner will check if the snapshot size and the volume size is on sync. If that's on sync, then the external provisioner will actually issue a create volume with the smaller size, and after that it will issue a node expansion.
No.
Isn't that?
No. If the user requests a larger size while restoring from snapshot, then the standard provider will issue create volume with larger size because that's what user requested. So as a result, the PV will have a larger size, but the PVC.status will have a smaller size because that will be the actual size of the data source. And then the kubelet will see this difference and call node expand volume.
Right, you said pv.status will have the smaller size?
PVC.status will have a smaller size, and pv.spec.capacity will have the user requested larger size. Yeah.
I guess the problem with that is we
That's
need
not
to
possible.
add permissions to external provisioner to modify the PVC, which it can't do today.
Yeah, the external provisioner only writes PVs. It doesn't modify PVCs. So it can write a PV with smaller size and add some flags around or annotations around for the external resizer or kubelet, but the PVC is kind of fixed. It will have the larger size unless we fix the PV controller.
Sorry, I'm a little bit confused here. So how does the resize works? I mean, like if from what I understand, so if the PV and PVC originally are like a smaller size, and if we want to do a resize on it, we just increase the PVC spec, right? And then a resize will be issued. So if that's the case, then I think from the external provisioner, we should create volume with a smaller size and let the CO to expand it to the right size.
So the way that resize currently works is a little bit odd in that we don't actually have a operation in the Kubernetes object that's kind of managing the state of what's going on. Instead, the capacity status on the PVC and PV are compared, and that triggers the various operations. And Hemant, you can probably add to what causes the controller side resize versus the node side resize.
Yeah, so the controller size resize is entirely based on the PVC dot spec dot size capacity and versus pvc dot status dot capacity. If the spec is higher than the status, then a controller size create volume is issued. But it also actually, the controller size also checks PV size at that point. So that, and also it checks what is the PV spec dot capacity. So if PV spec already matches the PVC spec capacity, then there's no need of any controller size expansion. On the node side, the only thing we check is PVC status dot capacity versus PV dot spec dot capacity. So theoretically, if we are going to create volume with the smaller size, like the data source size, and then let the resize flow take care of creating largest volume, it could work. Yeah, it could work. It just seems to me a bit wasteful, right? Most storage providers could restore, create from snapshot, create larger volumes automatically, isn't it? Sorry, Jan, you were saying something.
Yeah, like, yes, it is wasteful, but maybe it's the safest thing to do, because if we create PV with smaller sites in spec and status, then you can't bind this volume to the PVC, because PVC wanted something bigger. You can't bind those. I think we do have a check in the PV controller. And if we remove the check, then we allow binding to smaller volumes, which is, I don't know. I don't think it's something we want to allow.
Is it not when claim ref is already set, we ignore all the other checks?
Oh, I don't know. Maybe I would need to check.
That's a good point. So to summarize, what Jan is saying, that creating smaller PV might be problematic because the binding, it may prevent binding from happening.
Maybe.
Sorry, so does the external provisioner has the permission to modify the PVC? I mean, it can return the PVC with smaller size and then issue a resize. And then, then modify the PVC's spec to a larger size to trigger a resize, right?
So external provisioner, I don't think has permission to modify PVC. And even if it did, I think the external provisioner is not responsible for issuing the resize operations. Instead, all it does is update these PVC objects, and it depends on other controllers like the external resizer and the kubelet to issue the appropriate controller and node resize operations.
Yeah, so there are two options here. Like if we want CO to call node expand or expand the volume rather than plugin doing. One is that create larger volume in external provisioner, give external provisioner more permission to modify PVC at least. It doesn't have to explicitly call anything, but it does need to modify the PVC status to smaller size. That is option one, so that this will automatically trigger node expand volume when volume is mounted. Second one is provided the binding can happen, create a smaller PV and let the expansion procedures take care of expanding the volume and on both controller and the node. It's more expensive, and then also we have to be kind of mindful of what if the plugin doesn't have this capability, expansion capability. So like that was one more concern actually, like calling it by CEO, like what if the node expand volume is not implemented or not there?
Yeah, I think. Sorry, go
I was gonna
ahead.
say I'm not. I'm still happy with the previous month's decision on this. I don't see any reason to change our stance. Yes, there's a lot of plugins that need to be updated, but it seems like the least bad problem to have compared to all these other ones. Like, I'd say let's get updating those plugins. But that's my opinion.
I guess how painful would it be to go and update the plugins? And how do we communicate to plugin authors that they need to do this?
I thought that what we had agreed was we would add a test to CSI Sanity that would tell you whether you were doing it right or not, and encourage everyone to run the new CSI Sanity suite and pass it.
So right now, no plugin is implementing this. Does this mean that they're all non-compliant, or is the wording right?
No, I mean, how would you know if there's nothing to stop someone from doing the right thing today?
And I'm just saying, is the wording sufficient? Nobody has done this correctly. I'm just asking why. Why has nobody done that? Is the wording sufficient?
How do we know no one has done it correctly?
Uh,
Anyone that's doing a just-in-time file system size check at publish time and resizing file systems would, I mean, which is what the spec implies you're supposed to do, would pass that test. And
I guess it just kind of implies it, but it doesn't explicitly state it. So maybe we need to explicitly state it if that's what we want plugins to do.
Yeah, exactly. Because I mean, I cannot say not anybody has implemented it, but the most plugins that we have looked at, they're not.
Yeah, I agree with that. Like, I don't think any of the plugins I've worked on do this correctly. To be fair, but like I think the way to handle it is yeah, do what Michelle said, update the wording in the spec to make it more clear, and implement a test that allows you to easily determine whether your driver is compliant with the strict wording of the spec or not. And yes, the downside of that is lots of drivers will need to be updated, but that feels like the less bad option than these other, you know, it feels like hacks to try to get it to behave right.
Not that I'm disagreeing, but what do we have node expand call then for?
The node expand call is for when you've expanded an existing volume while it's attached to a pod, and you're not going to republish it. So
Okay.
you need to be able to go and expand the existing file system on the existing pod, because you're right. If they killed the pod and created a new pod and someone had this check, then it would just automatically get resized the next time it got published. But yeah, I thought it was specifically for the online resize case when you're not going to restart the pod.
Yeah, node expand volume is online for online expansion mostly. You don't have to restart the pods or anything. Personally, for me, I think that it's either way it's fine actually. If you're going to modify the plugin, you should probably update the spec and communicate to the driver authors. It might have been simpler to do this in the CEO, but yeah.
I don't think simpler is the right word. I think it might have centralized the hard work, but you'd still have to solve these technical issues around permissions and, you know, which where the code goes basically in Kubernetes.
Okay, any objections to saying we're going to update the spec to say that you should do a node expand as part of your node stage and adding a CSI sanity check to test that?
How are you going to test CSI sanity for this one? It's
You would need to, well, first of all, the driver would have to support either clone from volume or clone from snapshot. And well, I guess if it supported either of those, you create a smaller volume or a smaller snapshot, and then you create a bigger one, and then you publish it, and you verify that when you publish it, you get the bigger size.
I mean, you can get bigger size, but that doesn't mean that your file system is actually bigger.
No, I mean, like you do the publish, and then you do a DF on the resulting file system, and you check that it's bigger.
We don't do that in sanity test.
We have this get volume stats or something, this kind of call. That's, I don't know if it's mandatory, but we can get the volume size from there.
Is this going to work for plugins that just use a shared file system? Would those plugins even support snapshot or clone?
Yeah.
Maybe.
They do.
Yeah, and the expectation would be that the file system would expand immediately.
What about plugins that don't support node stage? It's optional.
Then it happens at publish time. But by the time publish is done, the file system needs to be the right size.
How would you do would like a DF make sense for plugins that use a shared file system?
Yes. I think it would, because the implication is, if you had a 1 gig file system and then you clone the volume to 2 gigs, like you better have 2 gigs or something resembling 2 gigs. It better be bigger than 1 gig in any case after that resize. Otherwise, what's the point of having a size on a shared file system? Like it has
I
to
guess
be respected.
if your plugin is doing a shared file system, it probably doesn't support resize, because the plugin won't really have permissions to resize the underlying shared file system.
Well, no. So the way it works with shared file systems is that all of the file system resizing happens in the controller expand or the controller create volume.
I'm asking
There's
about
no node.
plugins that just use the boot disk file system.
I wouldn't call them resizable, because how can you resize them?
I mean, certainly there are plugins that don't support resizing. And for those, the create volume call with the bigger size should simply fail, right? You say, I can't create something that's the size you want from the source that you asked for. But if it does succeed, then the thing you get better be the right size. I think that's the test. It's okay to say, no, I don't support that, creating a 2 gig volume from a 1 gig volume, because I can't do that. But if you say you can do that, then it better be 2 gigs.
For plugins that use a shared file system, like a boot disk, they don't have any control over the size, so I assume they just ignore the size parameters that come in. So I think that's okay.
Conform to the spec, right? I mean, if someone says I want 100 terabytes and you say okay, but you don't give them 100 terabytes, then you're kind of lying.
We are not explicitly saying that they have to implement node expand volume, because they may not implement node expand volume and they still internally could just resize. Like, for example, EBS driver may not have expand capability, but you can restore a snapshot to like larger size, and it still
But
can
the
But we're just talking about
if
the
they
basic create size now.
but if they don't, if say a driver doesn't actually support like node expand, then they should actually fail the create volume because they can't actually do a file system expansion on it.
Right. So node expand is sort of irrelevant for shared file systems, but controller expand can and should still work.
Just taking a step back, sorry, Ben.
If,
So if a driver does not implement node expand volume, maybe they haven't gotten around to testing the whole flow, but create volume and at node publish time, they could still call resize to FS on the file system, isn't it? Why they have to fail it?
I mean, so I have a CSI plugin that does NFS and it does do resizing, and all of the logic happens in controller expand. By the time controller expand is done, you've resized everything that needs to be resized. Node expand would be a no-op if it happened at all.
Yeah, so
for
I
at least
mean,
mine.
for the
So
case where say like a plugin hasn't implemented either controller or node expand, then they need to fail create volume if it gives a bigger size than the data source.
unless like, well, but if they have implemented controller expand and they do know how to do the controller side of the expansion, then they could correctly implement create volume from smaller size too.
Yes,
By doing
they
whatever controller
implement,
expand does.
if their controller expand already handles the node side, then that's fine.
But
But
there
I
is no
think if
node side with the shared file system. That's the difference, right? It's just the node is just mounting
yeah,
some remote
sure.
file system.
I think we're not really talking about the shared file system case anymore. We're just talking about in general, if a plugin hasn't implemented a controller or node expand yet, they would need to fail a create volume request if it's a bigger size.
Yes, exactly.
Why? Sorry, but why? I mean, they could still support it. They may not. They could still support creating volume to a lot bigger size. They could still do that. They may not.
But if they don't resize the file system in that create volume call and they don't implement any expansion method that will resize it, then they have to fail.
No, but
Yeah.
But by doing this, giving this opportunity to the plugin, we are decoupling this, and we are saying that a plugin, like the way I say, the plugin may have necessary code to actually to resize the file system on the disk, but it just may not have advertised node expand volume capability. Or are
That's
we
also true. Yeah. You could have the logic, but just not advertise the node expand
capability?
the
Yeah,
controller expand capability, and still do it in create volume, because create volume is guaranteed to be offline. And
or
maybe
not just create volume, but even in node publish or node stage, the plugin may still carry the code to do that, right? What I'm trying to
I
say is,
guess
if you,
though for those plugins though, like then this is going to become a requirement for them, right?
yeah, they have to do that now. But retroact, like asking plugins to, like, you can only restore to bigger size if you have node expand volume, or like any expansion capability, that is
right. So there's
not
a hidden
backward compatible.
capability here, which is the ability to create volumes from smaller things, and there's no explicit CSI level capability. It's just you try it and it either succeeds or fails. But if it succeeds, then it must follow all the semantics. Whereas by the time you publish it to a node, the file system has to be the size that was asked for. And
Yeah,
it's
I
just,
think,
so it's like another way of doing resize that's not explicitly advertised, but
Should it be a explicit capability?
what do you mean? I mean,
Should we add a new capability for, hey,
but
I support this,
I think the way you query that capability is you try creating the larger volume and see if it fails or not.
I think it's too late to add a capability. We already have a capability, and we're thinking of narrowing the scope of existing restore capability, which is yeah.
Yeah, it might have been good to have put a capability, you know, can clone larger or something, but given that we don't have it, you know, it's sort of an implicit capability that just exists. But the problem is yeah, if you implement it wrong, such that you say that you created something bigger from something smaller but you didn't resize the file system, then you're basically just violating what the spec expected. And we got to sharpen up the wording. And
so we're at the top of the hour. Do we have a conclusion about how to proceed here?
I want to basically continue with the plan from last month. And I also want to propose that we maybe have another one of these meetings to hit the rest of the agenda items, so we don't have to wait a whole month to get to them.
Okay, I can schedule a meeting in 2 weeks time at the same.
That might hit Thanksgiving.
You're right. That is the 25th. So maybe next week,
Yeah.
same time.
Next week
what I was going to suggest.
It's KubeCon. It's virtual KubeCon. Actually,
Oh,
North
that
America
is
time. It's actually
also true.
yeah.
I was about to suggest that we have quite a few of issues, so maybe we want to just 2 weeks are full, but like bi-weekly until we clear our backlog.
Okay, so are folks okay with the 4 weeks, or do we want to pull it back into 3 weeks? And then after that, we could do 2 weeks.
But if you change this regularly, it may overlap with our data protection when we're meeting. I think we are using the slot. It's like.
Well, how about we schedule a one-off in 3 weeks, and then we also keep the one that's 4 weeks away.
Okay.
And then and then maybe we need to do something after that.
Sounds good to me. 1, 2, 3. So 3 weeks out. Okay. I'm going to leave the conclusion here open, and we can finalize it next time.
Thanks, Saad.
Yeah, no problem. So we'll schedule another meeting in 3 weeks. Okay. All right. Thanks, folks. Take care.
Bye.
Thank you. Thank you.